Hi, I'm Steven Feuerstein, and I write practically perfect PLSQL.
Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Steven Feuerstein and I'm a PL/SQL developer just like you. This lesson is part of my series on programming with collections, and the focus of this lesson is working with Varrays, or variable size arrays. So what is a V-array? Well, first of all, here's the definition of a type of a V-array. So we create a new type in Oracle, we give it a name, we specify what type of collection it is, in this case a V-array. We specify the maximum number of elements, and then the data type of the element. So that's an example of a generic type declaration. A V-array, short for variable size array, is a type of collection that has an upper bound on its number of elements, which, by the way, makes it kind of strange that Oracle would call this, that Oracle would call this the variable size array because it's the most fixed in terms of the different types of collections. This is the only type of the three types of collections, a V-array, nested table, and associative array, that define an upper limit on the number of elements allowed. You set this upper limit when the type is defined, as I just showed you here, but you can also change it at runtime, and I'll show you an example of how to do that later. Other than the fact that there's this upper limit on the number of elements, it's quite similar to a nested table in the way it can be used inside PLSQL. So here's an example of a list of names of fruit. I can have an index value that I can use to iterate through the elements of my V-array, just as with an associative array and a nested table. The difference here is that's it. I can't fit any more elements into this V-array because I specified a maximum size of 5. An overview. The V-array was added in Oracle 8 as part of the object-oriented model in PLSQL. So object types, nested tables, and V-arrays were all added together. A V-array type can be defined in PLSQL inside a block of code or as a schema level type, in which case you can use it inside SQL, inside the SQL layer. And this, by the way, is an example of a schema level type, list of names, create or replace type, not defined inside a PL/SQL block. You must initialize a V-array before you can use it, and I'll show you examples of how to initialize and what happens if you don't initialize very shortly. And you have to extend to make room for new elements. So this initialize and extend steps are common to both nested tables and V-arrays. And the extend method is the one that you would use to make room in your collection. And you should check out the separate lesson on collection methods for details, but you'll be seeing examples shortly. So initializing V-arrays. Before you use a V-array, in other words, a variable you declared based on a V-array type, you have to initialize that type. And you initialize it by calling a constructor function, which means it's a function with the same name as the type, automatically provided by Oracle. You do not have to build these yourself. In fact, you can't. So here's an example of declaring a V-array type inside my PL/SQL block. I declare a variable based on that type, and I immediately initialize it as empty. So I don't provide any values, I simply call the function. I have to include the open and close parens if I don't include any values. And then I'm ready to go. Alternatively, I can declare my type, declare my variable, call the constructor function, and specify n number of initial values into my list. So this will automatically initialize, extend, make room for 3, and add 3 elements into my V-array. But if I want to, I can also call the constructor function inside my executable section and pass the values at that point, or initialize it as empty. In other words, you just have to call the constructor function before you try to do anything with that collection. Again, this is true of both nested tables and V-arrays. Also note that there is no need to initialize if you're populating a V-array with a bulk collect query, because you don't know how many rows you're going to be fetching in, so Oracle automatically figures that out and does the extend for you. Some characteristics of V-arrays, then we'll look at some examples. So first of all, no doubt about it, the defining characteristic of the V-array is the fact that you specify an upper bound on the number of elements. If you try to extend past that, you get an error. None of the other collection types have that constraint, although there is a maximum limit to the number of elements that can be defined in a nested table and associative array, you're likely never to hit them because they're so large. So V-arrays are only for circumstances where you know that there's an upper limit and need to specify that upper limit. V-arrays are always dense. This means that every element between 1 and the count in the V-array have to be defined. There are no gaps in between. You can't delete from a V-array. You can only trim off the end of that V-array. So you know that V-arrays are always densely filled from 1 to the number of elements in the collection. Every index value between 1 and that count are defined. And as I mentioned before, you can define it as a schema level type, and in this case, you can use it as a relational table column type. Okay, let's take a look at a bunch of examples. So again, the V-array example script is something that's a part of the demo zip that you can download yourself. Let's grab out these first pieces of code, run them separately. So I create a schema level type called list of names. It's a V-array with maximum number of elements 10. Each element is a string with a length up to 100. If I want to, I can grant execute on that type to public or a role or another schema. Then what I'll do is declare a happy family variable based on the list of names type. I initialize it, but I don't provide any values. And that means that before I assign the names of the 4 members of my immediate family, I need to extend. So happy family dot extend, and I can extend 4 all at once. After I've done that, I'd like to display the names of my happy family. So I go from 1 to the count, so that's 1 to 4, and I display the name at that location. And let's not try to delete an element the first time around. So I create my type, run my code, and whoops, let's try that again without all my extraneous output from my last runs. And there are the names of the members of my family in the order in which they were provided. So that's a very simple use of initializing, extending, and staying within the boundary. Now let's do it again, but instead of initializing, I'm going to skip that. Whoops, I forgot to initialize. I run the code, and it tells me reference to uninitialized collection. So if you ever see this error in your code, go to the line number specified. That's the first reference, the first attempt to use that collection. And then look to see where that collection should have been initialized and go ahead and add that constructor. So there. Now if I wanted to, again, I could have said, right now, Eli, Steven. And then I could have just extended twice and put Chris and Viva into 3rd and 4th positions. So by using Eli and Steven inside the constructor list, it automatically extended twice. I extend twice more. That takes me up to the 3 and 4. Let's do that again. And I get the same output that I saw before. So you get to choose where you want to specify your initial values. And this is one of the few places in Oracle where you can specify a list of values right inside the declaration section. When I declare a record, for example, I can't automatically assign the values to the fields individually. So that's a nice feature. Okay, so you saw what happened when I didn't initialize. Let's see what happens when I don't extend or extend insufficiently. So I'm going to make room for 2, and then I try to go to 3 and 4, and when I do this, I get subscript beyond count. So that error indicates that I've tried to allocate or I've tried to assign a value to an index value that is not yet defined. I didn't extend to match it. Let's go back to 4. And now let's try to delete. So what I'm going to do is try to introduce a gap into my collection at position 2. And when I try to do this, I get an error. Wrong number or types of arguments in call to delete. That's a fairly obscure error to get. It should say V-arrays do not support deletes. But this is what we're stuck with, so you have to make sure that you interpret that properly. You can't use a V-array with the delete method. All you can do is say I want to trim off the end of the list. So I could say trim 2, and that should remove these last 2. And I should have 2 left, so I should see just Eli and Steven. I run this code, and there's Eli and Steven. So the idea behind V-arrays is they're a more constrained and simpler model than nested tables or associative arrays. You specify the maximum length, and then you can trim off the end of it. But the core set of data is always densely filled, starting at index position 1 up to the count of elements. And if I try to go beyond that, for example, if I try to extend to 11, this is a V-array with a maximum size of 10, if I try to extend to 11, even if I don't use those elements, I get subscript beyond limit at line 4. So line 4, notice it doesn't tell me you exceeded the limit on the V-array, which would be an even better message to send us, but at least it clearly says you tried to go beyond what's allowed. In this case, what's allowed is a maximum of 10. Back to my example script. So here's an example of trying to delete the element. We just did that, so I'll get it out of here for future reference. So we tried to delete an element. Let's take a look at using the V-array inside a query. This is a feature that's supported for schema level types. So because I've defined my type at the schema level, this is a data type that's known inside the SQL layer, and that means that I can use the table operator to select information out of my V-array. So there's a separate lesson on using collections inside SQL in which I explore the table operator in much more detail, but to make sure you know what's possible, and then you can explore further. What I'm doing here is populating a list of V-array with my 4 names of the family. And then what I'm going to do is use a select statement to retrieve the data from the happy family list instead of iterating through it with a PL/SQL loop. And what I do is put that reference to the V-array inside the table operator, and that says convert or unnest this collection into a relational table format. Oracle has a fixed value or fixed column name for these scalar lists of elements, column underscore value. I can rename it, of course, to whatever I want. And then I can iterate through using a cursor for loop in this case and see my data. And there are the names of my family. So this is one of the really, really nice advantages of both nested tables and V-arrays, the fact that with a schema level type, you can blend in data from your PL/SQL code and your database. So for example, I could even say, take this and union, select last name from employees. So here's an example of merging, blending data from my local PL/SQL block. This is not inside the SQL layer at all, with data inside my table. And when I run this, notice you now see all the data merged together. There are employee last names. There's Viva. There's Steven in here somewhere too. So it's all blended together. Very powerful feature. It kind of gives you the best of both worlds, the programmatic capabilities of PL/SQL and the SQL set-oriented approach using the table operator. Now, one of the other things I mentioned you could do is use a V-array as a column in a database table. So let's take a look at that one. So this is a rather silly example. What I'm going to do is emulate China's one-child policy with V-arrays. So I create a V-array with a maximum number of elements 2, the list of parents. And I create another V-array with a maximum number of elements of 1, the children names. Now I hope that you never ever use a V-array with a maximum length of 1. That's kind of silly. If you just have a single value, you should have a single string column or whatever it is. Again, rather silly example, but it certainly points out the limit, that you can specify a limit with your V-array. I create a family table that has the last name or surname of the family, the list of parents, and the list of children. Here's an example of denormalized data structures inside Oracle. Oracle made famous the SQL language and the idea of normalized databases, fourth normal form, etc. So you might think this is kind of strange that Oracle would allow you to put nested tables or nested V-arrays inside another table, a relational table. This was added in Oracle 8 as part of the object model. From an object-oriented standpoint, this makes perfect sense. Collect all the related data together in one place. From a relational standpoint, we would have separate tables and join them together. They're just different approaches to doing the same thing. So you can certainly pursue both models inside the Oracle database now. So I create my family table with my 2 nested collections. And then inside my PL/SQL code, I declare my variables based on those types. I make sure to initialize. Here what I'm going to do is show you the limit clause on my parents just to reinforce that you can use this method to find out the limit. I will make room and assign the values for 2 parents. I will make room and assign the value for 1 child. And then I do an insert directly into the table. So Oracle makes it really easy to do this as long as the data types of my variables match the data type in my table column definition, same as whether it's a string or a date. Oracle takes care of all the details for me. Let's run this code. And if I look at the family table, what I find is that I've got a list of names and a list of names here, but just one. So there are the names of the two parents, there's the name of the child. So you can do this. Oracle makes it quite easy to do. And you'll see in the lesson on using V-arrays and nested tables inside SQL that you can also select from these nested collections. You can update the contents of the nested collections, and so on. So lots of possibilities of working with V-arrays. In terms of the valid V-array types, when you're creating a PL/SQL defined type inside a PL/SQL block, you can create a V-array of almost any PL/SQL and SQL data type. So I can have a V-array of Booleans. I could have a V-array of object types of other collections. There are some exceptions. For example, you can't have a V-array of cursor variables or exceptions. I'll show you an example of the problem you'll have when you try to do that. And also, when you define a V-array as a schema level type inside the database, well, then it has to be a V-array of SQL data types. You can't have a V-array of Booleans inside the Oracle database as an SQL layer object because SQL doesn't know about Booleans. Let's take a look. So first of all, I'm going to try to declare a let's make these V-arrays, sorry. Let's change table of. I did a copy and I didn't change my type definitions. So V-array, let's say 10 of. Much better. Okay, so declare a V-array of sysref cursors, cursor variables. Cursor variables point to rows and columns in the database, and Oracle doesn't allow you to maintain these variables as a state, in other words, in a list of things in a package level variable. Then I'll try to do a V-array of exceptions. You can declare things to be of type exception, but you can't have V-arrays or any kind of collection of exceptions. Let's try that. So index table of cursor variables are disallowed. And counted the symbol exception when expecting one of the following. So it doesn't tell you this type is not allowed. It simply tells you from a syntactical standpoint, this makes no sense. Then let's take a look at schema level types. Here's a schema level type, V-array of Booleans. And it tells me unsupported type in a V-array or table type, Boolean. And if I try to do the next one, now in this case, it tells me schema level type has illegal reference to HR employees. What I've tried to do here is declare a V-array of employee rows. Inside PL/SQL, I can easily do this and have it essentially emulate the structure of my employees table inside the PL/SQL code. Unfortunately, %row type is PL/SQL syntax. It's not recognized inside SQL, so you cannot do this, which is really too bad because it's a very convenient type of structure to build. So there are examples of a variety of limitations on your V-array of syntax. And the main thing to remember is that when you do a schema level type, you can only use SQL data types. I got a little bit ahead of myself. I showed you the example of creating the table, creating a V-array as a column type. So we've seen the example of this already. But as you can see here, if the type is defined at the schema level, it can be used as a column type. Here's an important thing to know about it, though. The way that Oracle stores and works with V-arrays as columns versus nested tables as columns is quite different. The V-array list, which again is constrained to a small size, is stored in columns either as raw values or lobs, in line with the rest of the row. And basically, depending on the total size of the data used by your V-array, Oracle determines which approach to take. But the main thing is that it's stored in line with the rest of the row. And that means that the performance of manipulating V-arrays as columns is better than manipulating nested tables as columns because they're stored separately in another table within the database. The other thing that's important about V-arrays compared to nested tables is that the order of elements in the column is preserved. So if I insert a row into a column, into a table, with a set of values in a V-array, A, B, C, then I know that when I query the data out, it will always be in the order A, B, C. But with a nested table, the orders might change. And again, I have a separate lesson on details on using collections in SQL to check this out in a lot more detail. Let's talk about changing the upper limit on a V-array. So as I've already shown you, when you declare a V-array, you specify the maximum size. Let's go back to my schema level type. So there's the definition of a schema level type with a maximum size. And so if I try to go beyond that, I get the subscript beyond limit. However, it is also possible to change this limit at runtime with the alter type command, a DDL command. So here's an example of saying alter my type, modify the limit, set it to 100. And I can say invalidate or cascade. And basically invalidate means that any types dependent on this type are set as invalid. Cascade means cascade the effect of this change to my limit to the other types. And notice I can also do it inside PLSQL as an execute immediate statement. Let's take a look at some examples. So in the VArray change limit, I define a type at the schema level with a maximum length of 10, and then I'm going to change the limit to 100. And in fact, right here, let's also add a little bit more code to demonstrate that the limit's changed. So what I'm going to do is create the type. I'll declare a VArray based on that type, and I'll take a look at the limit. So the limit method tells me how many elements are allowed inside that VArray. And I'll do it again after I modify it and set to 100, and then I'll set it to 200 and do it again. So let's try all of this code. So define my type with a limit of 10, display that limit. Up it to 100, display the limit. Up it to 200 using dynamic SQL inside a PL SQL block, and check out the limit again. Run my code. Operation not allowed on evolve type. So this is the kind of restriction you can sometimes get into with these data types because it has dependencies in other areas. Let's actually do a drop type names VAT force. We're just going to force a drop. I think that we won't get any of those errors. Let's get rid of all this stuff. Run it again. Okay. So because I did a drop with force, it dropped the type and broke all the dependencies and marked anything dependent on it as invalid. Then I created the type and went through several steps. And when I look, I see that the limit changed from 10 to 100 to 200. So you can make these changes at runtime. If you find that you're running out of room, you can say, well, let's make more room. I obviously made a mistake setting a limit of 10. Now, having said that, let's go back to my file again. What I then did was write some code inside the script to play around with changing the length of my VArray, the limit of my VArray, dynamically. And I found out something quite interesting. So let's grab this code, walk through it. So what I've done now is recreate my names VAT as a VArray 10. I've got a procedure called expand array, and the idea here is to see if I can expand my VArray dynamically inside my PL SQL block. So what I'm going to do is declare my list, maximum number of elements 10, automatically extend to the full set of 10. So make room for 10. I'll assign the value of 10 to every single element. I'll check the count in my VArray. I'll check the limit in my VArray, and they should be both 10. Then I'm going to say, and this is the kind of code you might want to write inside your own code, if my count equals limit, if I've reached the limit, I'm going to alter that type, and I'm going to double the size of my VArray limit. So modify the limit, double it. And then I check to see what the enlarged VArray is. And it's set to, and we'll see what it's set to. Then I'll extend and try to add another element. There should be room for it. If something goes wrong, I'll display the error message. And then what I'm going to do is try to declare another variable inside my exception section with the new type, the newly modified type, and see what its limit is. Before I do the expansion, I'm going to see what the limit is. Then I try to do the expansion. Then I check the limit after the expansion. Let's run the code. I know this is a lot of code to throw at you, but I want to make this important point. Let's do it again without all that other stuff left over. So the limit of names before the expansion, 10. The count is equal to the limit. I enlarge the VArray to, wait a minute, to 10. That doesn't look right. Enlarged VArray to 10. It turns out, and I discovered this after doing some experimenting, that even though it did change the limit, it did not automatically make that limit available for the currently declared V-array. So in other words, that V-array that I already declared still has the limit of 10. And then I thought, well, okay, maybe you have to declare a new V-array after you've changed the type, and then you get the extended limit. But no, I got the error, subscript outside of limit, when I tried to assign the 11th element. And even inside my exception section for my newly declared collection, the limit is still 10, only after my block terminated. And I came back out and ran a separate block that checked the limit of my V-array did it pick up the new limit of 20. So it looks like even though you can dynamically change the size of the limit of the V-array, it will not take effect in your current block of code. Now, having said that, I want to try one more thing, which is let's change invalidate to cascade and run this again. Perhaps because I'm setting it to invalidate, it's not allowing it to take effect. Run my script. And as I suspected, same problem. So it doesn't matter if you specify invalidate or cascade. You can change the upper limit of the V-array, but it will not take effect until the block in which that change was made terminates and your next block begins. So watch out for that one. Let's draw some conclusions. V-arrays can be used inside PL SQL code and inside the SQL layer, just like a nested table. You have to initialize with a constructor function. You have to extend to make room for new elements, just like a nested table. You should only use a V-array when you know that you have an upper limit on the number of elements that are going to go into your V-array. That's a fairly rare occurrence. But when you do know that, specifying the V-array limit is a nice way to declaratively assert that you can't have more than this amount in your collection. So I think it's pretty rare that you're going to run into the opportunity or the need for a V-array. But when you do, it makes for a very nice fit. And especially if you're going to be putting data inside a column in the table as a nested collection, whether it's a nested table or a V-array. Again, if you have an upper limit on the number of elements, like the number of months in the year, then you should definitely use a V-array because you will get a clear performance advantage over using a nested table.